Welcome to classes on inorganic chemistry. Today's class is class number 23. It is continuation of class number 22, and today's class is on chemical kinetics, and the topic is very small topic, rate and rate law, and it is a very easiest chapter. I think so far me concerned, it is a very easy chapter. And though you are on the advent of higher secondary final exam, so I will just make up the class with a bit first. So first of all, what is chemical kinetics? It is a branch of chemistry which makes study on the rate of a reaction and factors upon which rate depends, and also on the mechanism on which as to how the reaction occurs. This is all about chemical kinetics. Now, what is rate? So, if I take an example, say A plus twice B gives C. There are two things. One, these are reactant and these are products. You know it very well. So, in one term, there is disappearance of reactants, and on the other hand, there is appearance of product. So, disappearance of reactant is designated as of reactants. It is designated by the sign minus, and disapparent reaction. There are two reactants A and B I have assumed here. Both will be minus, and formation of product will be plus. So that means at the cost of the reactant, product is formed. So as time progresses, the reactant will decrease, and at the cost of the reactant, product will form. That's why reactant is minus and product is plus. So if you want to write the stoichiometric equation of this one, it's simple. It is very important factors, important term, stoichiometry. This is stoichiometry. In whatever the reaction is, say ammonia, nitrogen plus hydrogen gives ammonia, then what is the coefficient, whatever coefficient appears, you write in reciprocal form and go on writing in this way. This is stoichiometric representation of a reaction to represent. So this is the reactant and this is the product. Now, what is instantaneous? Rate. Let me first explain what is rate. Actually, this is a very important term and upon which a lots of questions, and you are to explain a lots of things. If you do not have idea on rate, you can't. First of all, what is concentration? Concentration is equal to mole per liter. This is very important thing. Concentration. Concentration of any term is assumed as mole per liter. And what is change in concentration? So initially the concentration of this is something, and finally after some time it has become something, say A1, A2. So what is change of concentration of A2 minus A1? That is del A. That is del concentration of A. So the change of concentration with respect of time, the time from T1 to T2, T1 to T2. So difference of time is T2 minus T1 is equal to del T. So change in concentration divided by change in time will give you the rate. This is rate. That is called rate of change of concentration. So concentration is mole per liter, and if you add here time, change of concentration with time is the rate. So what is rate? That is change of concentration, change of concentration, concentration with respect of time. Now what is concentration? Concentration is mole per liter, that is mole per liter. And what is time? Time is second. So rate is mole per liter per second. You should learn, this is very essential factor, essential term. So what is rate? Rate is equal to mole per liter per second. So now instantaneous rate, all are the same, but difference is change of change of change of concentration of reactants or product in an instant of time period. Instantaneous rate, and that rate is, earlier we wrote d a and dt. Earlier we wrote it delta d, and we have written as d, that is very small period of time d. Delta means just you can calculate 5 minutes to 3 minutes, 6 minutes, 7 minutes, like this. And when it comes as d, that is, it is from calculus, very small change with very small change of concentration with very small change of time, that is instantaneous rate. Only in capital delta you place delta of calculus. Take an example. Say a reaction of general form of the reaction AA plus BB equal to CC plus DD, a small b small d are the coefficient of the reactions, and when the concentration terms of A are multiplied, you raise the power as this. Mind that in each and every time this coefficient may not be equal to this power. That's why you have written X and Y. So rate of such type of reaction is written as K into, it is a constant, reaction constant, K is equal to concentration at the power X and B to the power Y. So this is rate. Rate constant equal to here K. It is a proportionality constant. Later on we'll calculate and we'll find out the its unit. So now what is order of the reaction? These are very simple things, and very often 1 marks and half marks is very often asked in your exam. So I am not giving much more importance upon these factors, because many of you know what is order. Order is nothing but the sum of the powers of concentration terms appears in the rate of a reaction. Sum of the powers of concentration terms of the reactant, concentration term of the reactant raised as power in the rate reaction, in the rate of a reaction, is called order of a reaction. Order of a reaction, it is experimentally calculated. You just keep it in your mind. Nothing is to learn by heart. Experimentally calculated. That's why you have not written a this to the power small a, this to the power small b. It is experimentally calculated terms. So order is experiment. It may be whole number, may be fraction. We will come across with some example. I have just today I will explain that may be fraction, but molecularity is always whole number. later on will come. So it is nothing but the sum of the concentration term of the reactants raised as power, which appears in the rate expression of the reaction. Now we know there are three types of reaction: zero order reaction, first order reaction, and number 3, second order reaction. Second order reaction and third order reaction. But very often you won't get four order reaction, but order of reaction is restricted to third order reaction. But there is one exception in type of organic chemistry. I don't know, have you got this one in organic chemistry? Cannizzaro reaction, auto oxidation of Cannizzaro reaction. The reaction rate order is equal to 4. Only one reaction you get in organic chemistry, order of reaction is 4. Now if you ask me why the reaction of the order of the reaction will not exceed 3, because in the next process, next chapter, we will coming the collision theory, that in the collision there will be some effective collision. So after, if you get the 3 reactants, more than 3 reactants, so it is not possible to have 3 reactants to attract an effective collision to get the result. That's why order of the reaction will never exceed 3, except in case of Cannizzaro reaction it is 4. So in short, it is a big concept, order of reaction, because what is order in actually, if I ask you what is order, actually it is nothing but the reactant species upon which rate of a reaction depends is nothing but order. Okay, so I am not going to deep, though I am going to complete the chapter. That's why what is required for your class exam, so also in entrance exam, I will bit by bit solve out each and every one today. You minutely follow the class. So now rate depends upon rate factors on which. So rate of reaction generally occurs concentration, pressure, nature of the reactant, catalyst, and inert gas, addition of inert gas. So out of this, let me explain a short one line upon these factors. Concentration, it is directly proportional. If you increase the concentration of the reactant, rate will increase. And pressure, you have already got in first year Rate&Law principle. Some reaction, the rate of reaction depends upon pressure, exo and endothermic reactions. So for time being, if you assume that if you increase the pressure, it will the rate of the reaction will increase, but that depends upon the Rate&Law principle. We will explain in next another chapter. Nature of the reactant, if the gaseous, this will gaseous reaction, gaseous reactant will react faster than the liquid reactant, and then solid reactants. So that's why the nature of the reactant also depends upon the rate of reaction. Catalyst is reacted not related to the rate of reaction, but catalyst increases the rate of reaction only because of the fact that catalyst does not take part in the reaction, that does not involve in the reaction, they are not absorbed in the reaction, they just reduced or lowered the reaction barrier activation energy. It lowers the activation energy so that more and more reactant molecule cross that level of energy and give you product. So this has indirect effect, and inert gas addition, it is another term. How we will find out the unit of 0 degree, 1 degree, 2 degree, 3 degree reaction units. This is a bit tough, but one thing I will show you, you can very easily understand. Say mole to the power 1 minus n. Let me explain it. Is you can't keep in your you can't keep it in your mind. That is the value of k. If you keep it in your mind, it is well and good. Otherwise, I am showing you a trick how to keep it in your mind, because this part is a very important one. Say a reaction A gives product, and I don't know what is the order of this reaction. So let the order of the reaction be n. So the rate is equal to concentration K into concentration A, and this is nth order reaction. This is the rate expression. So rate of the reactant of this reaction, rate is equal to some constant K and concentration of A. I don't know what is the power of this reaction. This is, I have assumed is N. So let us find out what is K. K is equal to concentration A to the power N into R. A bit earlier at the very beginning, I told you rate. What is rate? Mole rate, change of concentration with respect of time. Change of concentration with respect of time. What is change of concentration? Mole per liter is change of concentration divided by time is second. So this is mole per liter per second. So this is rate. So rate is equal to mole per liter per second. Now what is rate? Rate is equal to mole per liter per second. And what is concentration? Concentration is equal to what is concentration? Concentration is equal to mole per liter, that is mole per liter, and if you divide it by time, that is rate, mole per liter. So here this is equal to mole per liter to the power n. So if you simplify it, you will get mole to the power n, and here 1 minus n, here mole n, L to the power minus n. So if it go up, plus n minus 1, s minus 1, I have written earlier. This is K. This is K. Mole to the power n, you separate it. Mole to the power n, L to the power minus 1. Then simplify it, you will get mole 1 minus 1 liter, n minus 1, s minus 1, it is equal to K. So K is equal to mole 1 minus n, L, n minus 1, s minus 1. So this is the main thing. If you keep it in your mind, this will do a lot. Let's see how we can apply this to find out the unit. So for zero order reaction, n is equal to 0. So put n is equal to 0, you are getting value of K is equal to mole, L is equal to 0, that is 0, n is equal to 0, so for zero order reaction, K is equal to this. You can't learn it by heart, you should know this one. K is equal to mole 1 minus n, L, n minus 1. Then if n is equal to 0, we put the value of n is equal to this. For first order reaction, n is equal to 1, you put n is equal to 1. So this 1 minus 1 is equal to 0, mole 0, L, n is equal to 1, 0. This second, for first order reaction, n is equal to 1. So K is equal to s minus 1. So for second order, likewise, you put n is equal to 2, 1 minus 2 is equal to mole to the power minus 1, L, 2 minus 1 is equal to L, and S1. In this way, for first order reaction, zero order reaction, K, for first order reaction, K, for second order reaction, K, for third order reaction, you can find out the value of rate constant K, the unit of rate constant K, with the help of this formula. This is a very important one. So it has come from this, R is equal to K to the power n. So K is equal to R by A to the power n. So R is equal to mole per liter per second, and concentration mole per liter whole thing to the power n. And from this we have got, if you forget, you derive this and you find out, because very often this value of K is of importance, great importance. Action. Very simple. I am not elaborate it. It is very simple. You will get in books. I am telling you, these reactions which takes place with more than 2 steps, and all the steps involved in the complex reaction are elementary reactions. So the reactions which occurs or process more than 2 steps, with more than 2 steps, are called complex reactions, and all the steps which occurred in the complex reactions are called elementary reaction. Very simple. It is a very important term, very often asked in exam, and lots of question from AI or a NEET, and lots of competitive exam a question comes from this one. What is coefficient, temperature coefficient? It is seen that the rate of a reaction doubles with the rise of with the for every increase of 10 degrees centigrade, the rate of the reaction becomes doubles, and it is called rate coefficient, and it is designated by mu. That is, mu is equal to K of temperature 25 degrees centigrade to temperature 35 degrees centigrade. So it is 10 degree centigrade. There are lots of questions being asked with this. So in some books it is written, with rise of 10 degree temperature, rate of a reaction becomes double or triple or triples. Is called temperature coefficient. So mu equal to K 35 degree centigrade by 10. This is initial temperature. It is raised temperature 10 degree more. That is called temperature coefficient. Question, you are given a reaction thrice A gives you twice B. What is the formation of B? The reaction, if you write the stoichiometric equation, the answer will be minus 1 by 3 dA by you are asked to find out this one. Am I right? Therefore, dB dt is equal to, this is coefficient, this will go reverse of this. This is the answer. Plus dB by dt is equal to minus 2 by 3 dA by dt. So minutely follow. I am doing this very speedy way. This is very simple, nothing to explain. Very simple. So you are asked a reaction giving to twice N2O5 gives twice NO2 plus O2. All are gas. I have not written. And you are given the rate constant K is equal to 3 into 10 to the power 5 per second, and rate equal to 2.4 10 to the power 5, and you are asked to find the concentration of N2O5. Mind that to find the concentration, you need to write the rate of the reaction, expression of the rate of the reaction. So to write the expression of the rate of a reaction, you need to know the order of the reaction. Is it zero order? It is first order, second order, third order. But there is no way to find out how we can find out the rate of the reaction. Say rate of the reaction equal to some concentration of the N2O5. That much you are to write. But what will be the order of the reaction? It is not known to you. If you cannot find out this, then how can you find out this one? So you need to write the rate of the reaction. We have written rate of the reaction, but you don't know the order of the reaction, but there is an hint. That's why at the very beginning I told you that you should know the value of K. With the value of K you can find out a lot of things. So a bit earlier I have shown you that the value of K is per second. It is nothing but first order reaction. You see in back calculation, you see earlier I have done from the rate constant. So that the value of the K, we see that it is per second, it nothing but the first order reaction. Here there will be 1. So our rate is equal to R is equal to K into concentration N2O5 whole to the power K. So you are asked to find out N2O5. So N2O5 is equal to, what is N2O5? Concentration of R by K. You are given what is R? R is 2.4 into 10 to the power 5 and 3 into 10 to the power minus 5. You solve yourself, you can find out the answer. Mind that it is a chapter from where each and every day in NEET or AI and higher exam, lots of questions often asked. So minutely follow. These are the very building block of your idea. So bit by bit, I will proceed with the difficult questions answer. So this is a very simple one. You follow. Very simple question. Against A plus B gives you P, and you are given the rate becomes 4 times when the concentration of A is doubled. What is the rate of the reaction? Another point is given. So before solving out this question, I am giving you 2 tips. One tip: if the concentration of one reactant is doubled, and along with this another is also doubled, in the same relation, if the rate increases, then this is linear increase, and that type of linear increase I will show in graph in the second topic of this one. It implies that it is a first order reaction. If reactant is doubled, the order is doubled. If the rate the concentration of reactant is halved, the rate is also halved. So if it is in a linear way, that is, mind that we will apply this concept, it is first order reaction. If concentration of one term is doubled and the rate is quadrupled 4 times, and if you decrease, and it will be 1/4. So if it is in 1/4 type, it is second order reaction. 1. Number 3, if upon the increase or decrease of the reactant of any terms does not have an effect on the rate of the reaction, that is 0 order. Mind that if the increase or decrease of the concentration term of the reactants doesn't have effect on the rate, it is 0 order. If one is double, rate is double, one of the half, rate is half, it is linear, it is single order reaction, sorry, first order reaction. If one of the reactant concentration or concentration of the reactant is doubled and the rate is quadrupled, or it is reduced 1/4 or multiplies by 4 times, then it is second degree. So 3 point, you keep it in your mind. Here you are given rate becomes 4 times when concentration of A is doubled. 4 times when concentration, it is quadruple, means with respect of A, the order is with respect of concentration of A, the order is 2, second order. I have already explained. And the rate is unaffected if concentration of B is doubled. That is, with respect of B, with respect of concentration of B, you can write concentration of B, order is 0. So we have got from the discussion I have already explained, we can write rate equal to some constant concentration of A into concentration of B. So we are concerned with the order of the reaction. So from this discussion or the data available, we have seen that the concentration with respect of A is order of respect of A is equal to 2, order of respect of B is 0. Then we can write the rate equal to K into concentration A2. We need not to write B. This is the rate expression. And sometimes you may be asked to find out K. At that time, rate will be given and concentration A will be given. Therefore, K equal to R below A to the power square. I am not writing the complete answer for taking time as a bar. So I am telling you, for a certain chemical reaction, it is found that the order of reaction with respect of A is second, order of reaction with respect of B is third order. Order of respect to A equal to second order, order of respect to B is third order. Rate is equal to what? What will be the rate if both the concentration of A and B is doubled? I will do without doing anything. I will do verbally. But if in exam it appears how to do, I will explain. But I can solve it very easy way. So you say rate is equal to, you see, rate is equal to some constant into concentration of A and concentration of B. As per the reaction, the order of the reaction with respect of A is equal to 2 and order of reaction with respect of B is equal to 3. This is this. Am I right? So what is the question? What will be the rate? New rate. This is the initial rate. What is the new rate? If the concentration of A and B both are doubled. So if I am just telling you verbally, it is double means here 2, 2 square is equal to 4, here 2 is 8, it is 24. Am I right? Here it is 2, 2 to the 4, here it is 2, 2 3 the 8, and answer it is 32. Rate will be 30 times more than the first, 32 times faster than the initial. Now how we will solve it? It is verbally, just I am showing you how you will solve it. So you see, to get you marks, if it is given 2 marks, so you will write this is R1. Now what is R2? R2 is equal to K is equal to twice of A concentration and twice of B concentration 3. So you will get 2 to the 4. This is 2. This is 1. So 1 divided by 2 will give you R1 by R2 is equal to this term, this term, this term, this term. I am not writing, all these terms go out. So what I told verbally is the answer. So R2 is equal to 32 times of R1. Initial rate, the final rate will be 32 times of the initial rate. So if it is asked in the answer in the question in this way, and in entrance it is asked, so you verbally you do, you orally you do, you can do, you just do in this way. And if it is asked to do in mathematically, if it is given 2 marks, allotted 2 marks, you do in this way. This is very simple thing, nothing to explain, simple calculation. So you don't be confused, you don't be afraid of the questions. Sometimes this type of questions very often asked in entrance exam, higher entrance exam, so also in the class exam. So it is not tough, it is very simple thing. So you see, a reaction is given to N2 equal to 4 N2 plus O2 when you are given data minus D concentration of N2 by dt is equal to K of N2 N2 plus D N2 by dt is equal to K dash N2 O2 and D O2 dt is equal to K double dash NO2. You are asked, this is given, supply given, so it is supplied. So you are asked to establish a relation among K dash K dash K double dash. This is very simple. This is very simple. Just to say, you see, you write the stoichiometric equation of this. This very simple. You can write it in this way. Very simple. The stoichiometric equation of this one is, first one is minus reactant is minus and product is plus, we know it, the coefficient is reciprocal of this one, minus half of d and 2 by d2, and this is plus 1 by 4 d and 2 by dt is plus, again it is in product, so d concentration of O2 by dt. This is the stoichiometric equation. Now you just replace this value, very simple way, very simple. You see, minus d and 2 by dt is equal to K of N2. So you will get half and d and 2 dt is equal to K of N2 O5, and this is equal to, this part is equal to K dash N2 O5, and this part is equal to K double dash N2 O5. Am I right? Now you see, in whole parts we can cancel out these things. What we get here is of K is very simple. Don't get afraid of these things. Am I right? So in the exam there will be a lot of action to give the relation. So if you take these two, so you will get a relation half of this one. You establish a relation of this one, half of K, that is K by 2 is equal to K dash by 4. This is 2, that is K dash equal to twice K. If you take this relation, you will get half of K is equal to K2 dash. Therefore K is equal to twice K2 dash. So you will be given this, comma this, and a lots of other relations. So certainly you will tell that these two relations are correct. This is not tough, very simple, but the where that student a question is given that will make you surprise and puzzle how to answer. So just you write this stoichiometric equation and just you replace the value and cancels out all that. You will find the relation, which relation is correct and which relations are given in the structure options. You choose and you find the answer yourself. You see, a chemical reaction is given twice, NO plus O2 gives you NO2, and you are given that the reaction is found to be second order with respect to NO and found to be first order with respect to O, and it is told if the volume is reduced to half, find the rate. So first of all, I have shown you that rate is equal to nothing but concentration of at NO and concentration of O2, and we don't know what is the order of the reaction. So to find out the rate, we need order. So from the data we see the second order with respect of NO2. So it is second order with respect of NO2, and first order with respect of O. It is first order with respect of O. So we have written the correct rate expression of the given chemical reaction with us in accordance with the data given or supplied. Am I right? Now our question is the volume, relation of volume. We have not got any relation volume. We know the concentration. If the concentration increase, if concentration is double, if concentration is triple, if concentration is quadruple, if concentration is reduced to half, in this way. But we have not come across with volume. So volume and concentration, what does it mean? So volume, if volume is reduced, if volume is increased, the concentration will decrease. If volume is reduced, the concentration will increase. It is inversely proportional. So if the volume is reduced to half, the concentration will become double. Volume is reduced, concentration will increase. It is simple concept. If volume is reduced, concentration will be increased. Volume is increased, concentration will be decreased. If the pressure is given, concentration will be more. If the pressure is withdrawn, the concentration will be high, concentration will be low. So the volume is reduced means concentration. Here volume is equal to half of the initial, means concentration is double. Am I right? So if the volume is reduced to half, so find the rate. So now what is rate? So if the volume is reduced to half, means that volume, that concentration term, it is third bracket concentration term, that concentration term will be twice, and that concentration term will be twice. So you are getting 2 to the 4, 4 equal to 1, it is equal to 4k NO and O2. That is, if it is equal to 1, equation 1, so from 1 we can write it is 4, that part is equal to R. If you can give it R1, say it is R2. So rate will be 4 times of the initial one, or orally it is 2, 2 4 the 2 to the 4, and this is 4 to the, sorry, I am sorry, this is 4 and here it is 2, that will be 8, that will be 8. So the rate of the new rate of the reaction will be 8 times of this one. Or in other word, you can do, you write it 1 and you make it R2 like this 2, and divide 1 by 2, and for the beginning I have told you, you can do in this way also, as you like, you can do, you make it 1 and you make it 2, R1 R2. So divide 1 by 2 and you find the relation. It is another way. Both the way it is correct. Mind that concentration and volume are inversely proportional. And sometimes mind that this is a chapter which you do not have any burden up your brain or thinking. It is a very simple. It doesn't have any touch upon your body. It is a very light chapter. You can do yourself. Nothing is more in for. It is simple, very simple. Nothing is to think. So A plus B gives you AB. If the concentration of A is double, what will be the rate? We don't know. Say K, say rate equal to concentration of A and concentration of B. We don't know of what was the concentration. Let initial concentration of AB A naught and B naught. Therefore, say R1 A naught B naught. Am I right? So according to question, what's happened? The concentration of A is made double, but concentration of B remains as B naught. So by second condition, K into 2 into A naught B naught. So you are getting twice K A naught B naught. So here you can get from 1 K A naught B equal to R1. So new rate will be twice of the initial rate. So beauty of maths, very simple one, very simple. Do it orally. In the higher entrance exam, you do not have any space to do all these things. You should know how to do orally. Each and everything I will do orally. So you see, the rate become thrice. Simple 3. When the concentration of A increased to 9 times, A increased to 9 times, but what is the order? I don't know. That the order be X. So you see, beauty of maths, twice S equal to 1, therefore X equal to half, therefore order is equal to half. It is half order reaction. So if you asked, this thing is asked in your simple exam, so how will you do? You will write, say, rate is equal to K into concentration of A to the power N. This is fast reaction. Now R2 is equal to K into concentration is made 9 times. It is 9 times, increase 9 times, N is equal to 2. Am I right? So what will you do? R1 by R2 is equal to this divided by this is equal to A to the power N divided by 9 A to the power N. So A to the power N is cancelled out 1 by 9. So R1 by R2, 1 is rate is thrice. Say R2 is double of thrice, rate becomes thrice. So R2 is equal to thrice of R1, 1 by 9, and there is a N term. N is remaining here because A to the power N cancels out, 9 to the power N is there. So 1 by 9 to the power N. So you are getting 1 by 3 is equal to 1 by 9 N. That is 3 is equal to 9 to the power N. Therefore 3 is equal to 3 square X. Therefore X is equal to half. Whatever way, and lot of NEET exams and AI such kind of question very often asked, and it is a bit hard, and but you can answer it very easily. The temperature is raised. T for temperature is raised at 10 degrees centigrade. Rate of reaction is doubled. I have told you all the temperature coefficient. When the temperature of a reaction is increased by 10 degrees centigrade, it is found that rate has been increased 2 times or 3 times, and that is called temperature coefficient. What is temperature coefficient? Mu is equal to T of 25 degrees centigrade, T of 35 degrees centigrade. Means it is initial, it is final. What is initial? Initial temperature, that is T1, and what is final temperature is equal to T of 50 degrees centigrade. Now what is it? Is twice of temperature. What is the initial temperature rise? What is temperature rise? Temperature rise is 10 degree, and from 10 how much it is increased? It is 50. So 1050 is equal to 2 to the power 5 is equal to 32 times. Maybe entrance, maybe what type of exams you can do it orally. Simple way. 10 is the target. 10, if it is 10, we will get twice. 10 is the target. So up to 10, if it is given 20, whatever temperature rise is given, you give 2. And 10 is the fixed. 10 is when it is 10 degree increase, it is twice. 2 and 10 is fixed. And what is new temperature is given, you place it here. If it is given 40, you place here 40, and you write in this way. 2 4 the 16, it will be 16 times. Am I right? Because I am showing you this type of question asked in the NEET exam, that K is equal to E minus EA by RT. I have not coming to this one, in coming next one, RNS equations. Am I right? And you are given temperature is temperature is tending to infinity, what is the relation? You are given an option, say maximum of, you cannot give the answer, because when t is at infinity, 1 by t is equal to 0. So what you are getting, e to the power equal to 0, there is an a, a equal to 0. So you are getting k, a e to the power equal to a, it is collision factor. So rate constant is equal to collision factor. Maximum of, you cannot answer this question in AI NEET exam. Am I right? This is very simple things. This is not related to my present topic, so it is in advance. In next topic I will explain. So in the course of my discussion I have explained this one. So nothing is critical, is things very simple. And in the next topic I am coming to do a lots of bigger problem just orally, and I will show you a way this type of question very often asked in your class, in your finally higher secondary secondary year, how to do equation 1, equation 2, and lots of things to do. I will do each and every one orally within a fraction of minutes. You will see. Am I right? Questions where a lot of type of the question may be changed. For a second order reaction, what will be the rate of the reaction if the concentration of the reactant is double? It is not or half. Say a reaction A gives product. What is the rate of the reaction? Rate of the reaction K into A 2. And what is the order it is given? Second order reaction. First of all, you come to the first condition. If the concentration is double, if the concentration is double, that will be double to the 2 equal to 4. It will be 4 times. It is oral. So how will you do mathematics? So R1 is equal to K into A square. It is 1. And for the second condition, the rate has become double, twice a to the power 1 is equal to 2. You divide 1 by 2 and get the relation. You will find the rate of the final rate will be the 4 times of the initial rate. You divide these 2, you will get. Orally you can do, if it is twice it is 2, if it is half it is 1/4. So second one is what? If it is half, so second one, if it is half, the concentration is equal to half, that is half means 1/4. So answer will be 1/4. How will you do? How will you do? You put here. Again you see, for second type of the reaction, for second, for 1 2, the rate 1 K is equal to, this is equal to 1. So rate 2 is equal to K into concentration is make half of the initial, make 2. So make R1 by R2 and you go on doing the sum, you will get 1/4 of the initial. The final rate will be the 1/4 of the initial one. So this is simple calculation. What is tough or complexity of this? I don't get anything in this chapter. It is just you can do yourself from your mind. So this is the questions were given to 2 and 2 of 5 gives you 4 and 2 plus D. I am not giving here G and gas simple for simplicity or time, save of time. I have not written the complete equation in exact way. If the rate of formation of NO2 is equal to this, and what is the rate of disappearance of this, is what is formation? Formation is means formed and disappearance means this will be disappear and this will be formed. So you write this stoichiometric equation. The disappearance is always d of n2 of 5 by dt is equal to plus so we have written the stoichiometric equation and it is very simple. Again you can do orally. You see, rate of formation of NO2. What is formation? You need these two. You need these two. You take out this one. You need these two. You are given rate of formation of NO2 is 2.8 into 10 to the minus 3. What is rate of disappearance? From these two, disappearance means we need to find out this one. So this one is equal to d of n2O5 dt. It will go this one in a reversed way. Am I right? So you will get this and date of formation is how much? This is equal to 2.8 into 10 to the minus 3. These are the not problem at all. It is not sum. You can do yourself. So it is nothing but you divide this term equal to this. You are getting 1.10 to the power minus 3. Orally, rate of formation is this. You take this one below. Am I right? So you are stoichiometric. This one is above, in reciprocal of this one is equal to 2 half of into this means this divided by 2. You are getting the answer. So now one magical question answer in tabular form, the rate of the reaction, concentration terms and set of reactions will be given, and I will do each and every one orally. You see and look, you need not to practice, you yourself can answer yourself simply orally. Now with the help of the data given, we are now try to find out the rate expression, and it is a very important one, very often asked in the state exam, so also in the NCERT exam, or very often in the entrance exam, and very often many of you find that such type of sums are very tough, but this is very simple. I will orally explain, I'll orally just tell what is the rate of the reaction. First of all, let us take this one and I will tell you the technique. The technique is that at the part I told you that when the concentration is increased linearly, if it is double, then other is double. If concentration of B is double, other is double, means order of the reaction is 1. And if you find that if the concentration of one is double, other is quadrupled, it is second order. And if you find one is double and it is 8 times, then it is third order. And the fact is a bit tough with zero order. You will find that either the concentration will remain the same, the rate will increase, or the concentration will increase but rate will remain same. That means the uh, rate is independent of concentration. Am I right? So let us first take one example. So whenever you want to do orally, you will take one things. If you consider the rate of one reactant, concentration of one reactant, then you forget about other or keep other constant. You forget about other. Say, let us take this example. NO, twice NO plus Cl2 gives NOCl and given data, and you are asked to find this is the rate of disappearance of chlorine, initial concentration of NO, initial concentration of chlorine, and rate of disappearance of chlorine. Am I right? So you first of all find out, say A. What is the order of A? This to A is same. You do not have any clue. Now you see A is this and uh, A is this. So A is doubled. You forget about B. You forget about B. Say it is B. This is A. This is B. You forget about this. Now, when you see that it is doubled and see the concentration, it is quadrupled 4 times. Means the rate with respect of NO, order with respect of NO, order with respect of NO is equal to 2. Now come to this part, say it is B part. So you see this is 0.15 and this is 0.30. It is doubled and rate is also doubled. It is linear. Very simple. That is with respect of chlorine it is equal to 1. Am I right? Now come to next one. I will show how will you do this. If it is given in 3 marks in exam, how will you find out? But orally I am showing you. This is very important. You see here, for this set of reaction A B, twice A gives C plus D, A B C, and date of formation formation of D, rate of formation of D. It is rate of formation of D is given in this column, and column A is a concentration. So now you see here from A, you see the concentration of A is here fixed, but rate is doubled. So earlier I told you, if the concentration is fixed, there is change of rate, or if concentration increase, there is no change. Means here order with respect of A is 0. Order with respect of A is 0. It is 0 order. And now come to B. Here you see it is 10, it is 20. Forget about A. 10, 20. Rate is doubled. Am I right? So it is linear. It is doubled. It is doubled. Means linear. So B is equal to rate with respect of B is equal to 1. So the main thing is to find out the order. If you can find out the order, so you can very easily find the rate expression. Now Let us take one example to show you how it can be calculated mathematically. I have done it already. You see the mathematical calculation. Say for first set of reaction, say rate is equal to K into NO. This is X and Y, what are we have assumed it. This is rate expression. We don't know what is the value of X and what is the value of X. So I have predicted the value of X is equal to 2. That is second order, and value of Y is equal to 1. I have predicted. Let's see what mathematics says. So this is the rate. R is equal to K into this. So what is for first set? First set of the reaction is equal to K is equal to concentration is equal to 0.15 to the power X, again 0.15 to the power Y is equal to what is 16. This is 1. Now you come to second one. Just you place the value, nothing difficult. So if you get 1, 2, 3, 4 sets, so your first preliminary idea is to compare 1, 2, 3, 4 sets. Am I right? This sets is not given, but I will do how to find out. I will explain. But you will take 1, 2, 1, 3, 1, 4, 2, 3, 2, 4 in such a way that you take sum of these two is similar, so that it will be cancelled out. Am I right? So here we have got two things. So write R3. R3 is equal to K into 0.30 X 0.15 Y 2.403. So I have got three sets of reactions. We are not assuming this one because this rate is not given. We are asked to find out first rate expression first. Second, you are asked to find out K, and its in second is rate of disappearance of chlorine in set number 4. We'll find out. Just to follow. So if you divide 1 divided by 2, rate 1 divided by rate 2, so you will get this whole divided by this. So you are getting this divided by this divided by this will be cancelled out. You are getting 0.15, 0.30, Y is equal to 0.160, 0.120. Am I right? So you are getting here 1 by 2, you are getting 1 by 2, that is Y is equal to 1. Likewise, if you compare now these two, 1 and 3, if you compare R1 by R3, again you calculate, you will get X equal to 2. So what I predicted is the same answer. Am I right? So your rate expression will be, therefore rate expression will be R is equal to K. The first question, rate expression will be R is equal to NO whole thing to the power 2 and chlorine whole thing to the power 1. Now how you are to find out K? It is very simple, because rate, you take any one of this set 1, set 2, set 3, except 4, you take the rate, you put the value of rate is equal to 6.60 NO, the concentration of NO is equal to this, concentration of Cl2 is equal to this. This is known, and from one set number 1, rate is equal to 0.6. You put the 0.6, you will get the value of K. I think if you calculate, it is 177.5. Probably if you go through this one, so for my knowledge concern, this will be this. Am I right? Then what is the rate of disappearance of chlorine? Again, it is very simple. No need to explain in elaborate. Again, you take the set number 4. You take set number 4 and put the value of NO. You put the value of NO. The K is this. K is 177.5, and for this set you put the value of Na is equal to 0.25 and whole thing square, and chlorine as 0.2 whole thing to the power 1, that is nothing, and you calculate, you will find rate. This will be give you the rate. So this is the way how we can assume the rate expression. Actually, main fact is to find out the rate expression. Once you can find out rate expression, You can find out everything. Is equal to C plus D concentration, initial concentration of A, B, and rate of formation of D is this column and concentration is these columns. So set 1, set 2, set 3. From this, you are asked to rate law, and then you are asked to find out K, and then following are the sets of mechanism of this reaction. A plus B is equal to C plus E equal to slow step, A plus E is equal to D equal to fast. Second set is B is equal to C plus E slow plus. Two sets of reactions mechanisms are given with consistency. Which set of the mechanism is consistent with the result or rate expression you will calculate it out? Am I right? So those who cannot find out orally, they just take 1, 2, 3 and you write the expression, rate expression equal to K into A to the power X and A to the power X. Am I right? So sorry, this is not the expression, that is A plus twice B is equal to D, like this there was equation. So the rate expression is A and B to the power Y. So our main motto is to find out X and Y. So first of all, from first set you put the value R1 equal to K into this and this equal to 1, second, third, and from 1 to from 1 3, and you take this one, you will get X and Y. So for my knowledge concern, what I am telling that here the concentration of A is in the two place it is same, but here we see the rate is changed, means the rate of reaction is independent of concentration of A, that is here X equal to 0, that is the order with respect of concentration of A is equal to 0, that is A 0. Now you see it is double and it is also double, means it is linear, that is order with respect of B is equal to 1. So sorry yes, this is 1 equal to 1. If you do calculation at home yourself, you will find this way, the result will be like this. So what we find here is that is the concentration is rate is equal to this. So from this rate reaction, you see it is the reactant, it is dependent upon the reactant of concentration of B. So here this sets of mechanism starts from A, then B, A, then you get slow step C plus E, then A plus E is equal to D. But from second set, you see the reactants starts from B, and from the rate we see it is the concentration of reactant. What is it? Is the concentration of reactant. Rate is dependent upon the concentration of reactant B. So the second mechanism is inconsistent with rate law. This is the answer. These things has complicated in a complex way so that you will be confused. Am I right? But answer is very simple. I have discontinued my class at this point, and in the next topic I will come with another brilliant technique and ways and means how to solve a lots of questions answer orally without doing any sum for entrance. And if you want to do sum, whatever way I have shown, you do. Hope you have enjoyed the class. Thanks a lot for watching the video.